Lesson 78, force vectors at a point. Okay, these problems are a little challenging. They're not extremely difficult, except for the fact that there are a lot of steps. So these are word problems with vectors. Let's just read the problem and get started. Two ropes are attached to a point and pulled on with the directions and magnitudes shown. What is the resultant force on the point? So we have a point down here and we have two ropes that are pulling on it, and we want to know what the force of those two things combined is going to be. So this is just basically two vector problems. What we're going to do is draw our triangles. We're going to figure out each of the triangles, and then we're going to add them together. We did something like this. We just have an extra step on this problem. So here we go. This is your y, this is your x, this is your y, this is your x. We'll do them one at a time. So let's do this first triangle right here. So remember this, we get our y coordinate. We say y equals 70, which is the length of the vector. Y goes with sine of 45. You just pop all that in your calculator and you come out with, I'm doing the fast version, 49.497. Now we're going to do our x right here. So we get x equals 70 cosine of 45 degrees. Now the sine and cosine of 45 degrees are the same. So if you put them in the calculator, they're both going to be exactly the same. So we're going to get the same thing, 49.497. Now we're going to do the same thing with triangle number 2. So we get y equals, this time the vector length is 40, so we would say 40 sine of, that's 30 degrees. It kind of got erased there, but it's 30 degrees. And the other one would be x equals 40 cosine of 30 degrees. I didn't leave enough room to write the answer. So if we put that in the calculator, we're going to get 34.64 for y. And for x, we're going to get 20 because the sine, whoops, I did them backwards, I think. I did them backwards. Sorry about that. The sine of 30 should be 0.5, so we're going to get 20. And x is going to be 34.64. There we go. All right. Now, we're going to add our forces together. So we're going to add our x's together. Now you notice that this x right here is negative. So this is going to be, for some reason some of my numbers just like disappear on my screen. I don't know why. So this x is going to be negative. So when we add our x's together, we're going to have, for our x coordinates, we're going to have negative 49.497 plus this one is 34.64. Now remember the x is the rights, so that's going to equal negative 14.857. And then let's add the y's together. Both y's are positive because they're in the quadrants where the y is positive. So we add our y's together. So we get 49.497 plus 20. And we're going to get that our y's are equal to 69.50. So this would be your rights, and this would be your up. So your final, this isn't really your final answer yet. I'll show you what we have to do next. I think you can do everything up to this point pretty easily. Negative 14.857 right plus 69.50 up. So here's the tricky part. It says, what is the resultant force? So we need to have a magnitude and a direction. So this is the part that's going to be added onto this problem. So what we're going to do is we're going to take this coordinates, this is rectangular coordinates, and change it back into polar coordinates. So I'm going to make a little graph here, like such. Actually, I need more room on this side, so let me try this again. There we go. So I'm just going to estimate. It doesn't have to be exactly a perfect graph. It's just to help you get the answer. So right, we're going to go 14.86. So I'm just going to guess around at that right there. And then I'm going to go up 69 in some. So it's going to be a little bit higher this way. So that would be our point. This would be our point would be, we're going negative 14.8 this way. We'll just 0.9. And then our up, it's not even drawn to scale, but it's just to give us a picture of what we're doing. 49 up. So that's our vector. This is our vector right here. So we have to do a lot of work yet. We're going to build ourselves. This point right here is our negative 14.9 and our 69.5. So after I plot that point, I'm going to draw my vector, and then I'm going to draw myself a little triangle. My lines aren't being very straight here. Okay. Now, we need to find this angle right here, and in order to find the vector length, we need to use the Pythagorean theorem. So you can see how challenging this is going to be right now. So this is our vector length, which we're just going to call f, and we have to use the Pythagorean theorem. Now in our triangle, this side right here, the height is 69.5. And of course this distance is going to be positive, so that distance is going to be 14.9. So we're going to put this in the Pythagorean theorem. We're going to say the force equals, and it's going to be a squared plus b squared equals c squared. So it's going to be 14.9 squared plus 69.5 squared, and it's the square root of it. So we basically just plop all that in our calculator. Pythagorean theorem, a squared plus b squared equals c squared, and then we take the square root. So we're going to get our vector length is going to end up being 71.07. So that's our f, that's our hypotenuse, 71.07. Now we still need to get theta right here. I don't know if you remember doing this or not, but we always use tangent because we didn't have this. You could use sine or cosine, but we're going to work with these two sides. And tangent of theta is equal to opposite over adjacent. So let's look at this. Tangent of theta, the opposite, there's the opposite, is 69.5. The adjacent to the angle is the one right beside it, is 14.9. So we pop that in our calculator and we get tangent of theta equals 4.6770. Now what we want is theta. So to get theta, we would say theta equals the inverse tangent of 4.677. And when we put that in your calculator, you get 77.93 degrees. And we can finally write our answer. So we have this answer right here, and we have this force right here. So we write it back into polar form. The vector length is 71.07, and the angle that we're pulling it at is 77.93 degrees. So that is how you do these problems. We're finding the force that these two ropes had on this point is the exact same force as if it was pulled at an angle of 77.93 degrees, a force of 71.07. So what we're doing here, excuse Mr. Demai's voice here, it's turning, we're turning it into, we're going from polar form to rectangular form, back into polar form. So let's just try one more of these problems. Okay, I wrote here, a point is acted on by a push force and a pull force as shown. Find the resultant on the push force on the point. Okay, so this one's a little bit different. We have this push force right here. If we had to put this one in rectangular coordinates, the angle is 0. So, so this one, if we're going to find the... So, sorry, I got distracted by Mr. Demite talking very loudly in the background. Okay, so this force, this one, we have to figure out our left and right. We can't build a triangle because it only has a right push force. So our up and down is 0. So we would say this one is 10 right plus 0 up. And the fortunate thing about that is we are done with that one. Now we have to build our triangle on this one and do all the same things. So this is y, this is x, and we do the same thing. Then we'll be adding our left and rights together once again. So this one, our y is going to be 16 cosine of 30 degrees. And that's going to end up, whoops, sorry, that should be, hold on, Mr. Demite's leaving and I can concentrate again. This is going to be sine of 30 degrees. And x equals 16 cosine of 30 degrees. So we put those in. So we get 13.86 and we get, now I'm getting these all messed up until he leaves. This is going to be 8, sorry. If I put in your calculator, this is going to be 13.86. So we have to add these together. This would be your up. This would be your right. It's being pushed, so the direction is to the right, so it's not going to be negative. It's pushed to the right. So we add these together, so we add our ups. This would be 8 up, and this would be 13.86 right. And we just add those together. This one's slightly easier. Let's see, did I do these right? 13.86, 10, okay, good. So we get 23.86 right plus 8 up. Sometimes people don't know when I'm recording these things and then they walk right in and talk very loudly. Okay, so we have a point that's being pushed 10 and then pulled 16, and we're going to see what it would look like if there was just one force acting on it. So this is in rectangular, so we make a rectangular coordinate system and we plot the point. So here we go. This is the same thing as if you were given 23.86, comma 8. The right is the x-coordinate, the up is the y-coordinate. So if we do that, we would go over here, so this side would be 23.86, and then we would go up 8 like that. So our point would be out there. We draw our resultant force. This is the force. Let's see if I can even draw this. It's doubtful. Yep, I did it. Okay. And the height of this one would be 8. So you have to do the same thing again. You have to do the Pythagorean theorem. So you would say the force equals 8 squared plus 23.86 squared, and you would take the square root of that, and you get your force equals 25.17. That's how much force is being pulled on the rope if there were just one rope. And then finally we have to get theta, and you use the tangent. So you say the tangent of theta equals opposite, so that would be 8, over adjacent, which is 23.86. So you get tangent of theta equals 0.335, and then you take the inverse tangent. So you'd say theta equals the inverse tangent of 0.335, and out will pop your angle of 25.17. So your final answer is the resultant force. If you just had one thing acting on the point instead of a push and a pull, you would get, you have to write it in polar coordinates, the vector force is 25.17 at 25, oops, I already got that. I'm doing them backwards. Sorry about that. Yeah, they're both the same. No, they're not. This one was wrong. Excuse that one. Put it in the calculator, so you get 18.54 degrees. So, finally, you would get the force is 25.17 at 18.54 degrees. So sorry that's such a long lesson, but that's just the way it is. All right, so that's it for lesson 78.